Join me as I take the SPSS Now Correlation Descriptive tutorial game activity. I click on the link to start it up. We are at the Play to Learn site for the SPSS Now Correlation Descriptive. I'll go ahead and scroll down. Here's the tutorial game, but I recommend that you open up in full screen mode. But before we do that, let's just take a look at what we would be creating if we're using the real SPSS program. Because the purpose of this tutorial game is to prepare you for using the actual SPSS. So we'll go ahead and open up this sample APA style report. All right, so after the tutorial game, you'll be using the real SPSS to create the following things. SPSS tables, such as a correlation. This is for Pearson's R. It lets us know that the correlation between happiness and stress was a negative 0.529. We also have the statistics for one of our variables, happiness. You can see that there's the mean as well as the estimated population standard deviation. Likewise, for stress, we have the mean and the estimated population standard deviation, as well as a host of other statistics that we can use to evaluate normality. We have our graph for the happiness variable, letting us see that it looks like a fairly normal distribution, definitely not heavily skewed. Likewise for stress, it's fairly normal, not heavily skewed. Then for our class, we're going to be evaluating the information to assess whether the variable can be considered fairly normal or not, looking at our three tests of normality. Are the mean and the median fairly similar? We'll look at the skewness statistic, make sure that it's not indicating heavily skewed. And then last but not least, we'll also evaluate the histogram. If there's a failure of two of these tests, then the distribution is no longer considered fairly normal. But if it passes at least two of these, then it is considered fairly normal. So we'll be doing that for both the happiness variable and the stress variable. And then with all that information, we'll go ahead and write up the results. So here we have our scatter plot. And the results say that we've got a moderate negative correlation. And this negative correlation is between happiness, population mean of 5.00, an estimated standard deviation of 0.79, and stress with the population mean of 6.06 and an estimated standard deviation of 0.75 was observed among 17 behavioral statistics students surveyed spring 2023, and there's our Pearson's R equal to negative 0.53. We're reporting the estimated standard deviation using a lowercase s following the 7th edition of the APA style manual. SPSS gives us the estimated population standard deviation. It does not give us the population standard deviation, in which case we would have used an uppercase SD. And we'll talk a little bit more about that and how you can use the uppercase SD if you really want to, a correction you can apply. All right, with that said, let's go ahead and open this tutorial game in the full screen mode and get started with it. All right. So SPSS Now, correlations, descriptive. Our learning objectives: increased familiarity and confidence with SPSS, ability to create and modify graphs, in particular scatter plots, skill with evaluating the data in terms of is it appropriate for a correlation and should we analyze the data with Pearson's R or Spearman's Rho, and then awareness of APA style for writing up reports. So again, here's what we'd be creating with our scatter plot and our APA style write-up. This tutorial is going to include 5 main steps. Step 1, select statistics. In this case, it would be happiness and stress, and graph those variables, like creating the histograms. And then 2, do the normality test for our 2 variables. That's going to be important, as we'll see when we decide whether we're going to go with Pearson's R or Spearman's Rho to do the analysis. 3, graph the correlation, that would be our scatter plot, and evaluate it. When we look at the scatter plot, we're going to see, is this appropriate to continue and calculate Pearson's R, Spearman's Rho? it'll depend upon what we see there. 4, select the correlation coefficients. So then you select Pearson's R, Spearman's rho. And 5, awareness of APA style for writing up results. So we're going to go through each and every one of these step by step so that you can get comfortable with it. So this is our video walkthrough. And if you like to gain expertise with how you would interpret Pearson's R, then definitely there's lots of games that you can play at the playtolearn.io site to help you with that. Okay, so step 0, before we do anything, we'll go ahead and define the variables and enter the data. So our variables are going to be happiness and stress. We're going to indicate that they're scale and then record the data. And right now we're in tutorial mode. So here's what a brand new SPSS file might look like. We'll go to variable view and we'll go ahead and indicate that our first variable, which is happiness, and SPSS fills in the rest for us. We'll name our second variable stress. Again, SPSS fills in the rest for us. And then we'll use a scroll bar to go to the right. And we'll specify the measure for both these variables as scale. Both of them are Likert scale from 1 to 7. And it is fairly common for those to be treated as scale. Then we'll go to data view and record the data, which will be wonderful easy. So here's our data recorded, and now we're ready to continue. So now step 1, you want to consider what are the correlation requirements so that you know whether to go with Pearson's R to do the analysis or Spearman's rho. Pearson's R is the preferred correlational test. It's more sensitive to that correlation between the two variables, but it has more stringent requirements. Both variables have to be scale. Both variables have to be considered fairly normal. And there cannot be any outliers in either data set of either variable. If these requirements are not met, it's still possible to calculate a correlation coefficient, and that would be Spearman's rho. So with Spearman's rho, it's a lot more relaxed. Both variables need to at least be ordinal. It's not required that the variables are normally distributed, and it's not required that there aren't outliers. So Spearman's rho is always a good way to go when you're unable to use Pearson's R. So let's get started in evaluating our two variables, happiness and stress. So to do that, we'll go to the Analyze drop-down menu, go to Descriptive Statistics, and in previous tutorials we talked about frequencies, which is really nice for nominal, ordinal, and scale variables, gives you a lot of control. But in this tutorial we'll go with Explore, which is specifically for scale variables, and it does a lot of the work for us. So we'll click on Plots. We'll indicate we want histogram. We don't want any box plots. It just creates more output to have to go through. Continue, and we're done. Okay, so now evaluating for normality. So here's the descriptive statistics for happiness, and we're going to look in particular at the mean, the median, and skewness. So for our normality test, the first test is the mean fairly similar to the median? And we have 5.000 for the mean and 5.000 for the median, so check. And then the second test is the absolute value of skewness less than twice the standard error of skewness. So our skewness is 0. It can't get any more minimal than that. So definitely there's minimal amount of skewness, and it's definitely going to be less than twice the standard error of skewness, which would be 1.1. So happiness is looking pretty good here. In fact, it's already passed 2 out of the 3 tests. We look at its histogram, and again, it looks fairly normal. No problems there. Now we'll take a look at the normality test for stress. So again, looking at the mean and median for that first test, the mean is 6.0588, and the median is 6.0000. And yes, that's incredibly similar. And then in terms of skewness test, the absolute value of skewness is a positive 0.099 because we ignore the sign. And we compare that with 2 times the standard error. The standard error skewness is 0.550, so twice that is 1.10. And so yes, 0.099 is less than 1.100. So stress passes 2 of the 3 normality tests. So already it's done, it's in, it can be considered fairly normal. But we can take a look at the histogram, and yes, the histogram looks fairly normal. So both happiness and stress passed all 3 of the normality tests. So we'll treat them both as fairly normal. Okay, next let's take a look at the correlation. We'll do the scatter plot. This is important because both Pearson's R and Spearman's rho will not work if the relationship in the data goes up, 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 and then it goes down, 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 down. The relationship needs either to be consistently going up or consistently going down to be detected. If it goes up and it goes down, then it's like a wash. And the Pearson's R and Spearman's rho would say like nothing happened. And say like maybe the correlation was 0 if it's going up and down. So I'll go into that more in just a few moments. So to create our scatter plot, we'll click on Graphs, Chart Builder, and our variables are already defined as scale. And we're going to be creating a scatter plot. So we're going to choose from the scatter/dot. And the top left icon is our scatter plot. So we would drag that on over. And then we'll go ahead and set up our scatter plot so that stress is our predictor. So it goes on the x-axis and you would drag it. I'm just going to click it because it's a simulation. And happiness is our criterion. It's what we're trying to predict. And that goes on the y-axis. So you would drag it on over. I'm just going to click it because it's a simulation. So now we have stress on the x-axis, happiness on the y-axis. And anyone looking at this will go, oh yeah, you're trying to use stress to predict happiness. Now, this data you're shown here is not a preview. This is just example data. So if you're looking at this going like, oh, there's no relationship. No, this is just like pretend data, totally unconnected with your actual data there. It just lets you know you're doing a scatter plot. But when we proceed at this point, some of our dots are going to fall right on the x-axis. I know because I've already done it. And rather than having a dot fall right on the x-axis where you'd only see half the dot, I like to see things more clearly. So we're going to change the minimum for our happiness from being 4 to 3, just to make it easier to see the dots. So to do that, on the right-hand side, here's happiness, the minimum. I'm going to uncheck the automatic box, and where it says custom, I'm going to change it to 3. And then OK. So now here's our scatter plot. Again, happiness is our criterion. It's what we're seeking to predict. Stress here on the x-axis is our predictor. And you can see happiness is starting at 3. And you can see why, because at 4, here's a dot. And if it had been on the x-axis, you only see like half a dot. It'd be really small. When you're looking at the scatter plot, because there were so few choices to pick from, for happiness, people picked either a 4, 5, or 6 out of the scale from 1 to 7. And for stress, they picked either a 5, 6, or 7 on the scale of 1 to 7. So there wasn't a lot of variety, and it wasn't a continuous variable. So when we're looking at the scatter plot, we just see like a few dots here. And it's not clear to us whether it's one dot or actually represents lots of dots at this point. So let's go ahead and add a best fitting line. A best fitting line is a line that goes through the scatter plot that minimizes the distance between itself and all the other dots. And sometimes that can help give us a clear idea of what is the relationship, is it positive or negative, and how would we make predictions. So here we go, click continue. Before we proceed, I want to just pause and say, why are we looking at the scatter plot before calculating either Pearson's R or Spearman's rho? When we look at the scatter plot, it could be an indicator not to proceed with either correlation coefficients. So remember how I talked earlier about if the relationship went up, 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 and then went down, down, down? That would be a curvilinear where it looks like either like a rainbow or if someone's smiling, a big smile. In that case, the Pearson's R, Spearman's rho would give you a value close to 0, and you might entirely miss the fact that there's actually this beautiful relationship that's shown. You would see a relationship, by the way, that looks like this rainbow, for looking at anxiety and performance. So if anxiety is minimal, then the person might like sleep through their exam and not do so good on it. On the other hand, if their anxiety is like super high, they might blank on the exam, not do so well. But if it's at just the right level, then they might like really study and prepare and do really well. So there are variables where you have this like curvilinear relationship where it goes up and then down. And Pearson's R, Spearman's rho, not a good candidate for that. You would just show the scatter plot. But if the scatter plot looks like the dots fall along a line, that's perfect. Or if it just looks like a cloud of dots, that's totally fine too. It just can't look like a really clear curve going up and down or going down and then up. Okay, so I mentioned adding a best fitting line. Let's do that. So what you would do is you would double click on the graph to open it up in the chart editor mode. And here's our chart editor, and it has a drop-down menu. It says elements, so we click on elements, and we go ahead and choose the option fit line at total, and that's putting our best fitting line. And this is really awesome. It includes our linear regression equation even. So linear regression equation says that, hey, for any value of x, we can predict what y would be. So if you put in a value of 5 for stress, it will let you know, using this equation, what the predicted value of happiness would be. The only trouble is that this beautiful linear regression equation is right over one of our dots, and we don't have a lot of dots showing up on our scatter plot. So for that reason, we'll go ahead and remove the equation off the scatter plot. So we'll just click where it says attach label to line. We'll uncheck that box, click apply, and then close. And then we'll go ahead and close our chart editor. So here we go. Here's our finished product. We see a line going from like the top left, then going downward and to the right. That's consistent with this being a negative correlation. So we're good. We're in the clear in terms of proceeding forward now. We know that we can use Pearson's R. Why? Both our variables are scale. Both of our variables passed the normality tests. Both of our variables do not include outliers. So because we can use Pearson's R, we will. If any of those tests had been violated, then we would not have used Pearson's R. If one of the variables had been ordinal, go with Spearman's rho. If one of the variables had, or both had an outlier, Spearman's rho. If either of the variables was not considered fairly normally distributed, Spearman's rho. So it's nice to have Spearman's rho there as a backup. And if the scatter plot had been really curvilinear, like a rainbow or a smile, then we would simply have presented only a scatter plot and then described it for our reader and to let them know what that relationship is like. Okay, so to do the analysis for a correlation, we'll click on Analyze, Correlate, Bivariate because there's two variables. And we'll move both of those variables on over. And I'm going to go ahead and include Spearman's rho. Like, we know we don't need it, but it's just a good habit to have, to just have both of them there. So if later on you want to look at it, you can see it. And okay. So here we go. So SPSS gave us the output for Pearson's R as well as Spearman's rho. And you can see that they're fairly similar in value. Pearson's R is a negative 0.529 and Spearman's rho is a negative 0.532. So fairly similar. So when you look at the output for Pearson's R, there's lots of values here. The one that we need in terms of the descriptive statistics is just this negative 0.529 at the top right. So that's letting us know that it's a moderate negative correlation. There are other values here, and later on the semester I'm going to come back and talk about those. Okay, we have all the information we need, so we go ahead and proceed then with the APA style write-up. So from our SPS output for the correlation where we got the negative 0.529, we could go ahead and say a moderate negative correlation between happiness, and we'll have to go put those stats in, and stress, I want to put those stats in, was observed among the 17 behavioral statistics students surveyed spring 2023, comma, and then Pearson's R is equal to a negative 0.53. So we're rounding the correlation at the 100th spot. You'll notice that we have information about the participants included as well. Okay, so now let's include the information regarding our variables. So for stress, the mean is 6.0588. We'll round that to the 100th spot. So we're using an uppercase M, that's our sample mean, and that's consistent with APA style, is equal to 6.06. And then we're using a lowercase italicized s, again, consistent with APA style 7th edition, saying that that is 0.75. And that's because SPSS gives us the standard deviation calculated using the n-1. Okay, then for the happiness variable, again in uppercase M is equal to, and the mean is 5.0000, which we'll just report as uppercase M italicized is equal to 5.00. And the standard deviation is 0.79057, which again we'll round to the hundredths spot. And that's a lowercase italicized s is equal to 0.79. Okay, now it's totally fine to do exactly what I just showed you with the uppercase M equals and the lowercase s equals, both of those italicized. So for this class, totally fine to report it that way. But if you're like me, I like to have things more consistent. So since I have my uppercase M here is equal to 6.06, I like to have the uppercase italicized SD as well, indicating, hey, this is a standard deviation calculated with n instead of n-1, which is done by SPSS. So there is a correction that you can do, totally optional, but if you want to do it, to get that population standard deviation, you would take the estimate of the standard deviation that's given to you by SPSS and you multiply it by the square root of, and then this quantity, n-1 over n. So for happiness and stress, they both involve 17 participants. So for happiness, our population standard deviation is equal to 0.791 times the square root of the quantity 16 over 17, and that comes out to be 0.77. And for stress, the population standard deviation is equal to 0.748 times the square root of the quantity 16 over 17, and that comes out to be 0.73. So you could say a moderate negative correlation between happiness and then parentheses uppercase italicized M equals to 5.00, and then comma uppercase italicized SD is equal to 0.77, close parentheses, and stress, open parentheses, uppercase italicized M equals 6.06, comma, and uppercase italicized SD equals 0.73, close parentheses, was observed among 17 behavioral statistics students survey spring 2023, comma, italicized R equals negative 0.53. So if you want to use the uppercase italicized SD, just do the correction. But don't use the uppercase italicized SD and report what SPSS gives you. Whether it's a lowercase s or an uppercase SD, that tells us how the standard deviation was calculated. So you want to use the appropriate abbreviation. Okay, so that's it. We have our scatter plot. We've got our write-up. You'll reach the end of the tutorial. So at that point, you'll go ahead and click Game and work your way through this. And at the very end, provide your 4-digit instructional code, get your 3-digit completion code, and put it into the quiz. Take care.